first need to find the volume of the rock. And this is easy because we can say that in air, we know that the tension is going to be equal to the weight of the rock. And we know that the formula for the mass is simply the density times the volume times this density times the volume, and then keep the factor of g, the acceleration due to gravity. And so the volume of the rock would simply be equal to the tension force divided by the density of the rock multiplied by the acceleration due to gravity. And so this would be equal to 28.0 newtons divided by the density of the rock, 1,200 kilograms per cubic meter multiplied by 9.8 meters per second squared. And so the volume of the rock is found to be equal to 0.00238 cubic meters. And so inside the liquid, we have that the tension plus the buoyant force will equal the mass times the gravity. So here, the tension would be equal to the mass times the gravity minus the buoyant force. This would be equal to the density times the volume times the acceleration due to gravity minus the density of the liquid multiplied by the volume of the rock multiplied by g, the acceleration due to gravity. And so the tension force would be equal to the acceleration due to gravity times the volume of the rock multiplied by the difference between the density of the rock and the density of the liquid. And so this would be equal to 9.8 meters per second squared multiplied by 0.00238 meters cubed multiplied by here 1,200 minus 750, and of course the units kilograms per cubic meter. And we find that the tension force is going to be equal to 10.5 newtons inside the liquid. And so this would be our final answer. That is the end of the solution. Thank you for